Hello everyone. Today we are going to be studying the chapter Squares and Square Roots. Presented by the following students of class 8C. Abhipsha Hazra, roll number 1. Akriti Raj, roll number 6. Aditya Ratan, roll number 4. And Aniket Tiwari, roll number 8. We know that if we multiply a number by itself, we get its square. This square has 3 units each on each side. Area of the square ABCD is equal to side into side, which can also be written as side square, which is 3 units square, which is equal to 9 square units. Here, 9 is a perfect square, as it is a square of a natural number. It does not involve any decimals or fractions. Now, let us look at some perfect square numbers. Here are some perfect square numbers, and if we observe carefully, we will see that the squares of even numbers are always even and the squares of odd numbers are always odd. Let us look at some other interesting facts about perfect squares. Here is something interesting. We will pass all of these numbers through these doors one by one, and we will automatically get to know whether these numbers are perfect squares or not. Let us see another property. Here are the squares of some numbers ending with zeros. If we look closely, we will observe that even if a number ends with an odd number of zeros, the square of the number will always have an even number of zeros at the end. So, we can conclude that a number ending with an odd number of zeros is never a perfect square. Another property is that all perfect square numbers except 0 and 1 are either a multiple of 3 or exceeds the multiple of 3 by 1. It is also either a multiple of 4 or exceeds the multiple of 4 by 1. We know that 1 is equal to 1 square. 1 plus 3 is equal to 4, which can also be written as 2 square. 1 plus 3 plus 5, which is equal to 9, can also be written as 3 square. And 1 plus 3 plus 5 plus 7 is equal to 16, which can also be written as 4 square. Here we observe that the sum of n consecutive odd numbers is equal to n square. Squares of natural numbers composed of only digit 1 follow a peculiar pattern. First of all, the number of the digits in the product is odd in number. Since the digit is odd, if we pick the middle digit, each side will contain even number of digits, and those numbers are in reverse symmetrical order. So all these are some patterns formed by square numbers. Triangular numbers. Those numbers whose dot patterns can be arranged in the form of triangles are known as triangular numbers. Now, we will learn the ways of finding the square root of a number. There are various ways of doing so. Repeated subtraction method, prime factorization method, long division method, and estimation method. Let's find the square root of 16 using repeated subtraction method. We will subtract the first odd number from the question, then the second odd number from the result arrived, and continue doing so till we get 0. We obtained 0 in step 4, so the square root of 16 will be 4. Let's do the same with 25. We will get 0 in step 5, so the square root of 25 will be 5. Number 2. Prime factorization method. Let's find the square root of 1444 by prime factorization method. First, we will have to find the prime factorization of the given number. Then, we will mark pairs of prime factors such that both the prime factors in each pair are equal. Then, we will write one factor from each pair. Then we will find the product of the above factors. And we will get our answer. So, the square root of 1444 is 38. Let's find the square root of 361 by the same method. So, the square root of 361 is equal to 19. Number 3. Long division method. We use this method to find the square root of large numbers. Let's find the square root of 8281 by long division method. First, we will mark pairs from unit's end, like this. Then we will find the perfect square which is equal to or lower than the first pair from the left, which is 82. The perfect square lower than 82 is 81. It can be 64 also, but 81 is closer to 82 than 64 is, so we will consider taking 81. 81 is 9 square. So we will write 9 at the top and at the left side of the question as shown. Then we will multiply above and add below. Then we will add a box as shown. Then we will subtract the product from the number above. Then we will get the next pair down, which is 81. Now we will add same box above and below. And the number in these three boxes will be the same. Now we will use trial and error method to find the number in these boxes. We will have to guess what number can possibly be put in these boxes to obtain 181 as a product. Yes, the number is 1. Now let us put the number 1 in the required boxes. Now we will again multiply above and add below. We will subtract the product from the number above. And we got 0. The moment we get 0, we stop then and there. The number at the top will be our answer. So, the square root of 8281 is 91. Now, what about the numbers which are not perfect squares? Here, we estimate the square root. Number 4. Estimation method for non-perfect squares. Let's estimate the square root of 15. We will write the closest perfect squares which comes before and after 15, which are 9 and 16. The square root of 9 is 3 and the square root of 16 is 4. So, the square root of 15 should be somewhere between 3 and 4. So, let us take a look at the number line. We can see that 16 is closer to 15 than 9 is. So, we can say that the square root of 15 should be located somewhere at the right side of the number line. So, let's just be crazy and pick 3.9. 3.9 square is equal to 15.21. 15.21 is greater than 15. So, let's pick a number which is less than 3.9. Let's pick 3.8. 3.8 square is equal to 14.44. Now 14.44 is less than 15. So we will have to choose the one which is the closest to 15. 15.21 is closer to 15 than 14.44 is. So the square root of 15 is approximately equal to 3.9. Hope you enjoyed it. Thank you.